Welcome back everybody to our garage. This week we were so lucky to have a company called Hexagon here, and they laser scanned our Jeep so we can get a three-dimensional model to use it to design our components, the mounts for the components, and use it for our simulation activities. Hi everybody, welcome back. This is Electrified Veronika and we're converting a Jeep to electric. One of the things that we need to figure out is where do all the electrified components go? So we will need to mount some of the components here in the engine bay area, some of the components underneath the car. And one of the things that you can do to kind of analyze where everything goes is using computer-aided design, CAD models that can help you along. As you've seen in the last video, we have already shown you some CAD models that we found online, but these are not accurate enough to really design the components that we need for this Jeep. Then we used an app on the iPhone and really did a rough scan of the engine bay, which worked surprisingly well, but still was not accurate enough. But luckily, we have some friends at a company called Hexagon who are also Jeep fanatics, and they came over and scanned the Jeep in the garage, and we will get a 3D model from them that is accurate to within 50 microns. So Hexagon is actually laser scanning our Jeep, especially the engine compartment, and as you can see a little bit here underneath the car, so this will a lot help us design the right components. And now I would like to hand it over to you and kind of try to a little bit explain how that works and what we can see here.
You bet. Well, thank you for having us today, Veronika. My colleague Joe and colleague Scott are both scanning the Jeep at this point in time. We have two devices here today. We have the 𝗟𝗏𝗿 Absolute Tracker tracking the AS1 Absolute Scanner. And then behind us, Scott is using an Absolute ARM 7 axis with the exact same scanner on it. So we can share this scanner, the AS1, between a laser tracker and the ARM. And it's that first cross-platform scanner available in the portable scanning industry. But essentially what we need right now is for Joe working, have the ability to have line of sight from the tracker tracking the scanner. The tracker knows the XYZ position and the pitch, roll, and yaw of that handheld scanner that Joe is using. The accuracy is in the realm of plus or minus 0.02 of an inch out to 30 meters.
Exactly what we need, as you can imagine. It's a very, very accurate for us.
Accurate. Yeah. And actually for ranges for the laser tracker, we make a derivative that'll go 30 meters radially that way. So we can do very, very large articles.
What else are you normally scanning?
Oh, it could be aerospace, it could be automotive parts, it could be tooling related to doing composite layup. There's just a number of industries that scanning can support today. But where you'll find us is where a little bit better accuracy is necessary for people. The other place that you'll find us is when people don't want to put stickers on the parts, because in aerospace, stickers are FOD, foreign object, right? So you don't want to put that. So the benefit of both of our technologies here today is its absolute measurement. So as soon as we start pulling the trigger on the scanner, that's in tracker coordinates or in ARM coordinates. And then we can put a reference system in place so everything's in the same reference system. So if we move the tracker or if we move the ARM, let's say to the back of the Jeep to get that area that's hidden, we can do that and have everything together for you at the time of handing over the data.
That's wonderful. I imagine this is the first Jeep that you do.
Well, actually, maybe second, because Joe scans his own Jeep for aftermarket accessories. But first, electric Jeep for sure.
So the team has collected millions and millions of data points, and they are right now preparing the model for us. As soon as we get it, I can't wait to use it to lay out our concepts and our components.